まず比重計で1番のセル、プラス側の線がつながってる一番最初。
Okay, so he's checking first from the plus connected plus terminal, and he's checking the specific gravity.
そこの1番から比重を。
So he's checking from the very first battery connected to the plus terminal.
1.22
and that's at 1.22.
で2番
Number 2 cell
1.23
1.23.
これ全部していくの
yeah.
でこれここ
So he's
順番通り
So in order, he said you should check all the specific gravities of the cells in order.
で一番最後がマイナスのコネクターのところ。
And the last cell you're going to check is connected to the minus terminal. So the first cell is connected to the plus, the last cell is connected to the minus.
水がちょっと入ってません。
Oh, this one doesn't have so much liquid in it actually.
1.6? 16
This is a 1.16.
でこうやって24個セルを測ります。
And then check all 24 cells.
それをデータにこういうデータに記入していきますっていうのを
Then write all the data on your data sheet
比重
for all the specific gravities from 1 to 24. Even if they're really low readings, for example, the specific gravity, if they're all in the red, it's okay. If they're all in the yellow, it's okay. If they're all in the green, it's okay. As long as they all have consistency within each cell, it's fine. But for example, if they're all in the green except for one is in the red, that indicates that that one cell should be taken out. The next thing where you're going to check is the voltage. So now he's going to check the readings of all 24 cells.
だからプラスのコネクターから
So he connects from the plus
マ
terminal
イナスのコネクタ
to the
ー
minus connector,
それは最初と最後
the beginning to the end. And that reads 48.8 volts.
OK、
OK
これが24個のボルテージ
So that's the reading for all 24 cells is 48.8. It's like,
壊れてる
it's like the specific gravity. The readings on each cell is very important. You don't want to have one voltage from each cell to another to be too different. For example, he's going to show you. So starting from cell number 1 again, 2.48.
2番
Cell number 2, 2.08.
だから全部がダメっていうことじゃない
So even if the voltage readings are low, for example, all of them read above 2.0, it's fine. All of them read at 1.8 volts is what it would read if it was completely discharged. As long as there's some consistency, like they're all around 1.8 or all around 2.0, it's fine. でもどうやってなんかこれが悪いとなんか
だからそれを見るのはだからその比重計で一つだけ下がっているところ
So one point to identify it is, the specific gravity. You notice the specific gravity in one of the cells is quite lower than the others. Then that's a warning sign that battery is damaged or dead or should be replaced. そしてボルテージも多分
ボルテージもだから他のと比べて著しく落ちてるやつこの24個のうちに全部測った上でどれかが低いやつこれは高いけどこれは低いっていうのは低かったらそれ高いのと低いのがあったら低いのがもうこういうこれは全体で測って多分こことここが低かったの多分他に比べて
全部低くて一つは高いのがありますか
それはない
Okay. So generally, he identified the bad batteries by the mark, and he felt those were the bad batteries because the specific gravity was much lower than the other cells, or the voltage was much lower than the other cells. So that's why he put an X on these to identify that they need to be replaced. So okay, it's very important to take so what you do from the very beginning is take the specific gravity and the voltage readings of all the cells in order, like he said. Put in the additive, the required amount of additive in each of the cells, and charge it up. And you'll notice that after the charge that perhaps the suspect cells that you identified by the marks did not improve as well as the other cells. It would help to indicate further evidence that those cells need to be replaced. じゃあそのまあ一回全部データして、そしてこれも怪しいと思って液体を入れて充電して、やっぱりこれがダメって分かってから。So this is an instrument he would use to drill the hole. In Japan, it's a size 21. Perhaps in America, it'd be a larger size because the batteries are bigger. But as you can see, it's a grinding bit with a drill in the center and a hollow point, so you can drill and take out the cell. Right. So basically, all right, we want to take out this cell. So what he's going to do is drill a hole in here.
本当にこれ掘っちゃダメだと思うから。
Yeah, 大丈夫。
これはね。で、こんな感じで。
Then it'll become like this. It'll have holes in it. And 次こっちですね。And you have to drill the other side as well.
で、こう掘ってこんな感じで取ります。
And it'll look like this with the holes.
で、こうしたら、抜いたやつはここ。
And the taken out cells will look something like.
そうそうそう。こんな感じで抜いて。
Drilling either side, and you remove the cells as it is like that.
抜いて、ここを引っ掛けて、これで抜きます。
And with それ引っ張るやつあるね。
あれ、これは売ってない。
売ってない。
売ってない。
Okay. Well, you need to use your own innovation to perhaps putting something inside the hole and pulling it out, because it can be kind of hard to take it out. But the boss made something to make it easy to take. Yeah, it's an original device they made to help take out the cell. So what they would do is they would put this in here like this, and with two hooks lift it out. So this is the device they made. There's a variety of devices that you can make as well to remove the cells. So what they do is they do it like this to remove it. They don't sell this anywhere, so you might have to be a little bit innovative and figure out a way you can pull it out, like so. Okay. Yeah, there's nowhere to buy it, he says. じゃあそのセルを掘って、そして取って、ま
あいいやつ。
Yeah. He said once you take it out, put a good cell. Doesn't have to be new, but just a cell with similar voltage. So next is the most dangerous part of the operation. What these guys would do is they would take a vacuum cleaner. 掃除機使うでしょ。They would take a vacuum cleaner to suck out the explosive gases from the holes before they use these burners to weld it together. He would wet a towel. After he sucks out the gas, he gets a wet towel, places it over the cap. Not the cap. The cap's not here. It's just the hole. A wet towel over the terminal like so. After he's taken out all the gases. It's very important to use a vacuum cleaner to take out the gases first, then put a wet towel over the removed capped hole area. This device is a burner, and he would use it to weld everything shut. And after you weld, it'll look like this, and it'll be a tight fit. Lead has a relatively low melting point, so using these これ PB でしょ。
PB って
これ同じ。
同じやつ。
Yeah.
同じ素材。
This is a lead. This is basically lead, and he's going to be burning the lead on the top to weld it together. Okay. そしてそれもできたらもう終わり。
そう。これぜひ OK。これをきれいにやらないと、これはもう訓練しないとダメ。訓練というかこれはもう教え込まないと。
Yeah, this is not an easy process to do. It takes quite a bit of skill, and you need to make sure you have a really good fit melting it together. It takes some skill and practice, he said. he could teach you if you come here or we go wherever you're located. はい。そしてタオルを抜いて and then you put at which point you would put the cap back on the cell. そして
で充電します。
Then you charge it up. Okay, sorry, this is also an important key. But not just the cell you're working on, but the cells generally around the cells that you're working on. Around the cells. じゃあこれならこの周り。
そうそうそう全部。
Yeah. So let's say you're working on this cell. You need to do the same with all the cells around it. You need to remove the caps, vacuum out the gases, and cover the holes with a wet towel to prevent it from basically exploding. The gases from inside from exploding. So it's very important to be very careful with this process. 全部じゃなくても周り。
いやこの火はだからこうしてる時にこう外すから向こうに行ったりするの。
じゃあ全部一応。
だいたい全体的にこうするんであっても最低はここら辺までは。
Yeah. Especially, I mean, when you're welding it, sparks can fly, and if those get anywhere near the caps, it could cause an explosion. So, anything around the cell is just a safe bet to say. You definitely need to use a vacuum to take out the gases from all the cells, just in case. But at least, 正直全部. Yeah. He really recommends to vacuum out all the gases from the cells, just in case. でもカバーするのは
もう大体結構の範囲でするけど、まあここをやるんでも、まあこの辺まではやるよね。もう結構。
Yeah, from a pretty big area, he recommends to. I mean, you've got to vacuum out all the gases from all the cells, and cover the holes with the wet towel. In a very large area around the cell that you're working on, just to be safe from preventing an explosion. So, you know, it just never hurts to be safe enough. So he just recommends extreme caution when replacing cells. Ideally, you would want forklift batteries that would not even need cell replacement. But when you're getting your customers' batteries, I guess you never really know what you're going to get.
ちょっとでも火が当たったらドンっていくから。
その経験あったことある？ある。He said he's had some experiences of exploding gases. Even when he's working on a cell like this, a little spark would fly into this cell and cause a little explosion, you know, a fireball coming out of the cell. So you need again to take real caution when welding the cells and making sure all the gases are out of the cells before welding.
これ時間1個に30分かかりました。
So now I'm going to go in the process of the best actual situation you could run into when getting a forklift battery. So from the beginning, you would take a chart and you would measure the complete voltage of the battery from cell 1 to cell 24. This is being a plus side and the minus side. They're connected like this. You take the voltage of all 24 cells, and then you would mark the voltage from the plus terminal. This is cell number 1, cell number 2, cell number 3, cell number 4. You would take the specific gravity from all the cells from 1 to 24, mark it down on your chart. Then you would take all the voltages from cell 1 to 24 and mark it on your chart. In the best case scenario, the specific gravities are all about the same, the voltages are all about the same, at which point you would add the additive to each of the cells. This battery is a 400 amp hour battery. It'll last 5 or 6 hours. So, according to the chart, it's about 10% of each cell according to the capacity. So this 40 would be like 40 milliliters of the additive straight into each cell. Okay, so you've added the additive into each cell. All the specific gravity and voltages seem about the same. And you would just hook it up to your forklift charger, which will automatically charge the battery. Ideally, you want the battery's voltage to go back up to 1.28, which means a completely full charge of your battery. Sometimes it won't completely go back to 1.28. It might just go up to 1.25, 1.24 specific gravity. So that's not a bad thing, because in the process of charging and discharging, through the process of over a week, you'll see the specific gravity and the capacity slowly return to 1.28. So as long as the cells are relatively consistent with the same specific gravity and voltage, you shouldn't have a problem with your batteries. So that's the absolute best case scenario for repairing a battery. One of the worst case scenarios you'll probably run into is where a few of the cells our voltage or specific gravity is too low relative to the other cells. It's only relative. There is no too low or too high. If it's all consistent, it's okay. Even if it's all low consistent, it's fine. If it's all high consistent, it's fine. But inconsistencies is what you want to look for. You find inconsistent voltage and specific gravities in the battery, you would mark it with an X. Once you've identified the suspects of those possible bad batteries, you would add the cells, add the additive to each of the cells and charge it. At which point you would identify, you would mark down the specific gravity and voltages again of each of the cells. And if you do not see any improvement relative to the other cells in your suspect cells, if you don't see any improvement, then you know these need to be removed. Sometimes your suspects would, the voltages would and specific gravities would go back up, at which point you don't need to remove the cells. But let's just say at the worst case scenario you need to remove the cells, you would need to go to this operation, again, drilling the ends of the cells with a driller, and removing the cells with whatever you can, like the boss's homemade contraption he made. Yeah, it looks like that. If you've seen it before, the homemade contraption. You can make up something yourself to remove the cells, but just be a little bit creative and I'm sure you could find a way to remove it. So difficult about telling the warranties for the batteries. For example, he has a friend at the BS tire company in Japan, and they go through new batteries within 6 months, even though the warranty on the battery might be 4 years, because they're lifting tires all day, all night, 24 hours a day, and when you're using your forklift batteries like that, it's only going to last 6 months. And those guys don't get any warranties on their batteries because that's how much they abuse it. So each customer is going to use the battery in their own special way. If they only lift light loads, they only use 2 or 3 hours a day, it could last 10 years. But if they're using it 24 hours a day lifting heavy loads, it could last only 6 months. So at times it can be impossible to guarantee any kind of exact warranty on the batteries that you fix. So at the very least, I guess you would at least give it 1 year, and at least you'll be able to, for sure the customer will be able to use the battery more than the cost of it would cost for a new battery. So giving the warranties can really be a tricky situation depending on how much your customer abuses the battery. So keep that in mind when thinking about refurbishing costs for your customer.